The reason the answer is no, just in case you're curious, is, you know, this is a parabola. Maybe we should know that. It's a parabola. And anyway, to be one-to-one means it has to pass this horizontal line test. And this one doesn't. That's one quick, easy way to put it. So no, it's not one-to-one. It is a function, but it's not one-to-one. One-to-one has to pass the horizontal line test. So by knowing what he looks like real quick, I can easily say no. That's a cubic function. Is that one-to-one? You know, I mean, you could deal with the details or not deal with the details. I mean, again, what I saw was a cubic function, and my brain quickly thought of this. And so if it's a cubic function, I think it is one-to-one. I mean, again, I didn't really position him correctly. He's really pushed over 7 to the left, blah, 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 but that doesn't matter. He's a cubic function. I think he is one-to-one. Not all cubic functions, but this one. Yeah, this one is. Is this one-to-one? Again, it's kind of about the horizontal line test. You know, maybe I should plot some points and see. What that horizontal line test said, though, is that for every y, there only better be one x. But let me see what I got here. 4, 6. 4, 6. Okay. 3, 9. 3, 9. Okay. Negative 7, 14. Negative 7, 14. Okay. This point's not here. 1, negative 5. 1, negative 5. All right. Any problem passing the horizontal line test? I don't see any problem passing the horizontal, right. If I would have had a couple of points on the same line, right, that would have been 1 y with 2 x's. That would have been not one-to-one, right. It didn't happen. You remember this, don't you? This is easy, right? I mean, again, I don't know what you've done, what you haven't done, what you've practiced, what you've thought about, but we talked about this once, and it was a real easy concept. You know, you can plot points for this function. That's kind of what they want you to do. But after you plot points for this function, how do you plot points for his inverse? You don't really need to plot points. What you really need to do is just take all these and switch them. That's the idea of the inverse. All the x's become the y's, all the y's become the x's. So I should plot some points and see what these values are, but I bet these values are going to be these values, and these values should go over here. But I should fill this chart in and then flip it, and it should be this chart. Right, right. All right. Well, that's easy. What about, I kind of think I should look at the quiz, maybe. Do you guys want me to look at the quiz? Or I haven't been to 4.2 yet. Should I go back to 4.2? You don't have an opinion? Maybe you don't have an opinion. Let's see what's in 4.2. This was supposed to be composition. A lot of composition. Maybe some profit and cost, because besides composition, you're also maybe adding and subtracting functions, and that's good for profits and costs. This is composition, though. Can you stick one function into the other function, right? I guess you can do this, right? F of g of x means grab the entire g function and stick it into f right there, and clean it up and work it out. Then they want you to do the other one. I think you could do this composition. I did a lot of that. This might be interesting. Let's see what's going on here. The total revenue function is that revenue function. I see that. Thank you. The cost function is this. Thank you very much. And part A, they want the profit function. All right, well, this isn't composition, but you know what it is. This, I don't have to tell you this again. It's revenue minus cost. I put the cost in parentheses because I am going to subtract the entire thing. You know, revenue minus cost is profit. So we got that idea, I hope. And all I'm doing is subtracting. And so let's see what I get. Hey, after I subtract, I'm going to put it in kind of in order. And so I'm going to call that, I'm distributing this negative sign here, and I'm going to call that a negative x squared. I'm going to have a negative 20x. When I subtract it from this, I'll have 540x. This is positive, minus 20x is this. And then I'll have a negative 30,000. So you guys with me? That wasn't difficult. I was subtracting there. And really only had one term to combine there. But there it is. There's my profit function. Watch this. They want to know the number of units that give maximum profit. This is good, man, because this makes me think of chapter 3. How do you get maximum profit?
Vertex.
It's a vertex of a parabola. And, you know, here I am. I should maybe realize that I got an upside down parabola. I got an upside down parabola, and it's going to be a maximum when it has a vertex. This is a good problem. This is makes me recall the vertex. Really wasn't a chapter 4 idea necessarily, but we need this. This is a good idea. The vertex is negative b over 2a. So negative 540 over 2 times negative 1. Those negative signs are going to cancel, and this is 270. This is x, by the way. This is the x value of the vertex, 270 units. If I sell 270 units, I'll have maximum profit. Find the number of units for maximum profit. Good old vertex, x value of the vertex. Part C, what is the maximum profit? Well, that's the profit. And so that's the y value of the vertex. So what do I do now?
Plug in the
Thank you. Plug in the 270, right. That's how you get the y value. You have to plug in the 270. This is a good calculator problem here. A lot of big numbers here. But if I plug the 270 in, that gives me the y value of the vertex. I got to square it, negate it, multiply that, add that, subtract the 30,000. I get some kind of profit. Cool. So I'm not really doing it. I'm not really typing it in, I guess. But I'm helping you just a little. I like that question. But it's not, it's partly chapter 4, partly chapter 3 kind of question. I like it. Huh. Here's these words quadratic and linear. That ought to be pretty easy for you, I guess. Here's another revenues and costs. This one's kind of easier. This is some composition. All right, enough of this. What does the quiz look like? So I go to assignments, and maybe way down at the bottom I can find my quizzes. But also I can do this right here, quizzes and tests. And there's a chapter 4 online quiz. Is there any good questions here? Oh yeah, this is my transformations. This looks pretty good. This is 4-1, these transformations. You know, I'm going to hand you back your quiz you took. You did pretty good on that. Transformations, this is a lot of good transformation stuff. Composition. Remember this? This was, mentioned slightly in class one day here. The monthly cost, here's a cost function. That's the cost function. And then they want the average cost. the average cost. And if you remember once I told you that if you take the cost function and divide by x, that's average cost. And there was kind of a symbol for it. The symbol for it was C with a bar over it. It's a new function. You get it from the old cost function. You take the old cost function, which is the cost of the total cost, and divide by each unit, the number of units, and you get the average cost per unit. It's very logical. The total cost divided by how many things you built is the average cost per unit. And it's symbolized like this. So it's that cost function divided by x. I think it looks a lot like A, don't you? Looks like A. Cost function divided by x. That's all. Yeah. Yeah, find the profit function again. We just did that a little bit. Subtract, of course. Hey, we might have not have done this in a while. Let's talk about this little guy. This is, again, this harkens back to some stuff we did earlier in the semester in a way. I like this stuff, so it keeps coming back. Listen to this problem. Manufacturer of DVD players has fixed costs of $8,500 and variable costs of $80. See, I don't know, you guys, I'm a little worried about you. Do you recall maybe how to come up with a cost function based on that? It uses the word fixed costs and variable costs.
So the fixed cost is like the y-intercept one, the one that's going to be on the end without a
variable.
Without a variable.
Yeah. And the $80 per DVD player. See, right, there's a lot of different ways to think. I like the way you're thinking. You can think very logically and say, okay, it's going to cost me $80 for every DVD player. Remember, the number of DVD players is called X. That's what X always is. So I think it'd be 80 times X. Plus, we have some fixed costs that don't depend on X of just $8,500. So when you have fixed costs and variable costs, this is how you present your cost function. Yeah, that's exactly right. Check this out. We sell these DVD players for $160 per unit. You may recall once that I tried to tell you that revenue was just the price times how many you sell. So the revenue is pretty easy here. The revenue is the price you sell them for. You sell them for 160 times X. So I read these words, and this, again, this was kind of chapter 2, maybe chapter 3. I mean, we have talked about this previously. It wasn't necessarily a chapter 4 topic. To read those words and come up with these equations. But it's not that hard. It's nice and logical, too. So, but you have to remember a couple ideas. Anyway, now what do they want? Now they want the profit function. Of course, profit is this revenue minus this cost. So when you distribute the negative sign and collect like terms, you're going to get 80x minus 8,500, I guess. And you're done. Right. Part A. Are they all answers A? Is there always answers A? Is that the deal? I'm just kidding. It's a cubic function. Yeah, this is pretty good stuff. Hey, this is a good one I bet you haven't done. Find his inverse. You know, when we are told to find the inverse, we had these two methods. Smith method, which, whatever, it works okay, but I told you it didn't always work. And then the book method, which does always work. See, and this is an example of when the Smith method doesn't work. So I've sort of gravitated toward the book method. All right, anyway, here we go. If I want to find his inverse, I want to do the book method. What's the book method? Switch x and y, call that x. Call this y. Right, switch x and y. And now solve for y. And because it's in the denominator, it tends to throw students off. how am I going to solve for y? It's in the denominator. But you got any algebraic ideas? What would you do? I would multiply by the quantity y plus 9. To get it out of the denominator, I would multiply by y plus 9. What happens over here is it cancels, and you're left with 2. What happens over here when you multiply by y plus 9 is you get y plus 9 times x, of course. And then I think you can solve for y. There's a couple ways. Some students might choose to distribute, but I might not. I think I'll just divide by x. Y plus 9 equals 2 over x. Subtract 9 and you're done. 2 over x minus 9. This y is the inverse function. This was f of x. This is f inverse of x. Now, check this out. Is this up here? I got a feeling he may not even be up here. Yeah, see? Look, he's not even up here. 2 over x minus 9. All right. It is up there, but it's disguised. If I got myself a common denominator, then I would see it up there. You know how to get a common denominator? This is 9 over 1. This is 2 over x. What is the common denominator? Of an x and a 1, I think the common denominator is x. What do you have to multiply him by? Nothing. He's still a 2. What do you have to multiply him by? An x. So it's 2 minus 9x over x. That's getting a common denominator, and that would be a different looking inverse function. It's the same thing I had a second ago, but with a common denominator, I think that choice is up there now. Although they have the two numbers reversed, but there it is. Negative 9x plus 2 over x. That's the inverse function. Let me show you something. I could have got that if I would have distributed. Watch this. If I distribute right here, I get xy plus 9x equals 2. Trying to solve for y, move the 9x over. 2 minus 9x. You guys with me? Trying to solve for y, divide by x. 2 minus 9x, the whole thing divided by x. That's the inverse function. So, I don't know. I've done algebra 3 ways here for you. That's how algebra works. You can do it a lot of ways. But we got our answer. That took a little work, solving, anyway, because he was down in the denominator, it took a little extra work. And actually, the Smith method won't even work on that. You can't do it. And this is kind of cool. There's another one of these square roots to try to solve. All right, listen, I probably ought to do this one. You ready? Because this is, I don't think we've done one this difficult yet. It showed up here in the quiz. Let's do this one. It might be about done. So you're supposed to solve for x, and it's these. You got 2 square roots equals 1. Anyway, so I think you should get 1 square root by itself. So I'm moving one of them over to the other side. So I'll have the square root of 2x plus 3 equals. I'm moving this one over, so it'll be a 1 plus. This will come over and be plus the square root of x plus 1. Okay. So now I'll square both sides. Square, that means grab this and square it. Hey, that's the easy part. That's a 2x plus 3. Okay, on the other side, you have to grab it and square it. But listen, again, the comment is you do not square each term. You square the whole side. That requires you to FOIL this. Foiling this is not that big a deal. It is 1 plus this square root, times itself, 1 plus this square root. So here I go. Foiling would be 1 times 1. Good job. 1 times that square root is one of those square roots. That square root times a 1 is another one of those square roots. And then finally, that square root times that square root is just x minus 1. Awesome. That's what happens when you have to FOIL that other side. These problems, this is, again, kind of the worst problem in chapter 4. This double, you squared both sides, you got rid of this square root, but you still got a square root to deal with. We're going to have to square both sides again. But before I square both sides again, let me get everything on one side, get this square root by itself. So what this is it's 2 of these square roots. Hey, what's kind of nice is these 1's canceled. See that 1 and that 1? They canceled. But I think I better take this x and move it to the other side. I'm subtracting an x. How you guys doing? Following all my arrows and lines? And I'm doing algebra, right? So I got these square roots together. I think I'm ready to square both sides again. On this side, you square this entire side. That requires FOILing. On this side, it's a multiplied 2 right there. This is not FOILing. It's just squaring everybody in here. You do have to square the 2. It's a 4 multiplied by, what happens when you square the square root? X minus 1, free and clear, out of the square root, of course. On this side, FOILing that out. Okay, x squared plus 6x plus 9, right? I've done millions of those. That's what happens when you FOIL it out. Whew. Dude, we finally got somewhere. No more square roots, but a beautiful quadratic equation to solve. I mean, these are good problems. They only take half an hour. Distribute that 4, move some stuff over, collect like terms. I get an x squared here. What am I doing? Subtracting a 4x, so that's a plus 2x. I'm adding a 4, so that's a 13. Oh my God. This is a tough problem. Did I do this right? You guys are supposed to be checking me. Yeah, I screwed up. Hang on, I screwed up. This was an x plus 1, and then when I wrote it, I wrote x minus 1. Where's my checkers? What's wrong with my checkers? All my damn checker pieces fell on the floor. All right, look. That's an x plus 1, that's an x plus 1, this is an x plus 1, this is an x plus 1, this is an x plus 1. This is an x plus 1, this is a plus 4. So then instead of, now I'm subtracting 4, so this is a 5. You guys with me? Oh, wait. Oh, I screwed something else up. This was a plus 1. And if this was a plus 1, it didn't cancel with this 1. Oh, my goodness. All right, hang on. I made one little mistake. It ruined my life. All right, hold on. We got it. It's a plus 1. Here we go. This is all accurate. These 1's do not cancel now that they're... So let's see. What am I doing here? I'm moving this x over. Right. Moving this x over. That's an x. This 1 plus 1 is a 2. Right? 1 plus 1 is a 2. I'm bringing it over, so I'm subtracting a 2. That 1 plus 1 is a 2. I'm moving it over. I'm subtracting a 2, so this is going to be a 1 here. Awesome. And what's left here is I'm adding those together. That's 2 of these square roots. All right. I think I'm fixed all my errors. Now what? Square both sides. Yeah. Square him. Square him. Okay, here we go. Again, this is the 4 times the quantity x plus 1. That's easy to square. It's not 2 terms. It's not a binomial that you FOIL. It's just, this is multiplied by this, you square both of them. This is added to this, you have to FOIL it, and you get x squared plus 2x plus 1. Cool, if I distribute the 4, let's see what happens. X squared plus 2x plus 1, this is 4x plus 4. Subtract and move some things over here, I'm moving down here. I get x squared minus 2x when I subtract the 4x. I'm subtracting 4x. I'm also subtracting a 4, so that's a negative 3, equal to 0. Woohoo! There's my answer. Oh shit, I mean that ain't my answer. That's just my quadratic form equation, and now I should solve it, this quadratic equation. I think it factors. I think it factors real nice. I think it's a nice x and an x and probably a 3 and a 1. How about a -3 and a +1? A -3 and a +1. When you set that equal to 0, though, your answers are +3 and -1. Right, you guys? When you set each factor equal to 0, those are your answers. Woohoo! Those are my answers. Man, that was a good problem. Square both sides. Square both sides again. Deal with the quadratic. But see, I'm so happy I got these answers, and then you got to remember something. What do you got to remember?
You gotta check them.
Yeah, you got to check them. That's kind of disappointing. I mean, I got all the way here. I'm so damn happy, and now I'm not done. I got to check my answers. Let's check them. In the original problem, let's check them. If I plug in a 3 in the original problem, it is 6 plus 3, which is 9, the square root of 9. I'll just write the square root of 9, but we know what that is. Minus, when I plug a 3 in that original problem, that's the square root of 3 plus 1. That's the square root of 4. Does this equal 1? Well, that's a 3, and that's a 2, and yes, 1 does equal 1. So that's awesome. The x equals 3 just checked. Let's try the -1. In the original problem, when you plug in a -1, that's -2 plus 3, so that's a 1. It's the square root of 1, which is a 1. Minus, when you plug a -1 in there, that's a -1 plus 1, so that's a 0. Square root of 0 is a 0. Nothing wrong with that. Does that equal the other side, which is a 1? I'll be darned, it does. So both my answers check, and that's the answer on this one. Ooh, wait a minute, which one? A, I guess. They're all A? The answer's A for every one of them? Is that what you guys do? Just go A. All right, it's getting toward the end of class here. Yeah, here's some more of these inequalities that we practiced a little bit. Find your answers, test the regions. You might have to build a profit equation. If you've got cost and revenue, you might need to build a profit equation to answer a question. All right, I'm going to quit. I'm going to quit. But one thing I'm going to do is hand you back your quizzes.